Okay, next example, same thing, still solving the system of linear equations. Like I said on the last problem, to be consistent here, I'm not saying this is the only way to do it, but to be consistent, I am still going to eliminate or get rid of the x's. And if you have another way or you would like to get rid of something else, that's okay. But just to be consistent, I am going to get rid of the x's here, just that I don't keep changing it up on you each time. So I'm going to start off by working on the top two equations to get rid of the x's. Now to get rid of my x's, I need to make the second equation have a -3 there. So I've got to multiply this whole equation by -3 so that that will cancel out with this +3. So I'm going to rewrite the top equation. I'm going to leave it alone. That's going to be 3x minus 2y plus 4z equals 1. And I'm going to multiply this whole second equation by -3. So -3x minus 3y plus 6z equals -9. And let's add that together now and see what happens. X's cancel. -5y plus 10z equals -8. Okay, so that's working on the first two equations. So now I'm going to come down here and I'm going to work on the second and third equation. To cancel out the x's here, I need to multiply the second equation by -2 on the second equation to make those x's cancel. So I'm going to do that. I'm going to multiply the second equation by -2. That's going to be -2x minus 2y plus 4z equals -6. The third equation down here at the bottom, that one didn't change. 2x minus 3y plus 6z equals 8. Add them together. X's are gone. That's -5y plus 10z equals +2. Okay, so now I'm going to take these two smaller equations and I am going to put them together and work on those. -5y plus 10z equals -8. -5y plus 10z equals +2. If I try adding these like they are, nothing's going to cancel, but like on the last problem, if I multiply one of them by a -1, then I will be able to cancel something out. And I'm going to kind of run out of room here, so I'm going to go ahead and to multiply all this by -1, what will happen is all of these will change signs. So this will turn into +5y minus 10z equals -2. And then I'm going to just bring this down and rewrite it underneath that. So -5y plus 10z equals -8. So now if I try adding those together, the y's cancel, the z's cancel, so I have no y's and no z's, and then that's supposed to equal -10. Well, I don't know about you, but I don't think that 0 equals -10. So this is one of those weird situations where you really don't have a solution, because 0 does not equal -10. So this one right here is no solution because this is a false statement. That is not true. 0 does not equal -10. Now, if you got something that said 0 equals 0, or say 10 equals 10, then that would have been an infinite number of solutions, okay? Because that would have been a true statement. All right, but 0 does not equal -10, false statement, so no solution. Okay, this little box right here telling you about the one solution, infinite, no solution, that probably should have been before the previous example we just did, because we just did a no solution problem. Let's work on number 5 and see what happens with it. Same thing as before, let's get rid of the x's just to be consistent. So let's work on the first two equations and get rid of the x's. To get rid of the x's, I need to multiply this top one by -2, so it will cancel out with the second one. So let's multiply all the way through. -2x minus 4y plus 14z equals +8. Second equation didn't change any. 2x plus 3y plus 1z equals 5. Add them together. X's are gone. You get -y plus 15z equals 8 plus 5 is 13. Okay, let's come over here and let's do the second and the third equation. Okay, so to make these cancel out, we are actually going to have to multiply both of those by something. Now, if you don't want to do that, you don't have to use the second and the third equation. What you could do is you could put maybe the first and the third equation together. So let me get rid of this for a second here. Okay, let me get rid of that. It's a little bit bigger here. Okay, instead of doing the second and the third, why don't we do the first and the third? And if we do that, then we only have to multiply this top equation by -3, and then that makes it a little bit easier. So let's try that. Okay, so that's going to be -3x minus 6y plus 21z equals 12. We didn't do anything to this bottom one. We're just going to leave that. 3x plus 7y minus 36z equals -25. Okay, add those. X's are gone. 1y minus 15z equals -13. Now we need to put these together. -y plus 15, it's a z, it's supposed to be a z there, equals 13. Positive y minus 15z equals -13. We can go ahead and add these together because we notice that the y's will cancel and the z's will cancel. So the y's are gone, the z's are gone, and 13 and -13, those are gone. So everything cancels. So we have 0 equals 0. This is a true statement. Everything cancels out, so this is an infinite number of solutions. That one is infinite. Okay, there are times when we will have some systems that are what we call non-square. We have, like here, we have 3 variables, but we only have 2 equations. So the system doesn't really match up with the number of variables that we have. That's why it's called a non-square. So we can still solve this, but really instead of doing the addition or the elimination method, we have to do usually substitution. Substitution. Sorry, that writing is very sloppy there. This pen's kind of hard to use. Substitution. Okay, so in order to substitute, what we have to do is we have to get an x or a y or a z by itself. And I'm going to look at this little small equation down here. This would be easy to get a z by itself because I have a little lonely z. So I'm going to get this z by itself, and z would equal 4x. So what that does is it allows me to substitute 4x in for my z up here and see if that can make any progress. So I'm going to substitute 4x in for the z and see what happens. So I'm going to get x minus y plus 4, and in place of that z I'm going to put 4x, and then that's going to equal 3. So I'm going to simplify that. X minus y plus 16x equals 3. And that's 17x minus y equals 3. Now, I actually am going to have to do a little more substituting. So now that I have this simplified, I'm going to solve this for y. I'm going to put this into y equals, and this will be y equals 17x minus 3. So now I have something that I can substitute for y, so I can put y equals 17x minus 3. I can put 17x minus 3 back up here where y is. I can take all of this and put it right there where the y is and substitute something in for y also. So let's go back over here and substitute one more time. So I'm going to have x minus, and in place of this y, I'm going to put what we had for y, so that's 17x minus 3 plus, I'm going to substitute in for z again, 4x equals 3. So let's simplify this. X, distribute your negative sign, multiply there. Oops, that's not 116. That's just 16x. Okay, let's combine like terms here. That's x minus 17x. That's negative 16x plus 16x. That's 0. No x's. And then so we just have 3 equals 3. So the x's have completely canceled out. And that is a true statement. That's true. So that means this is an infinite number of solutions. Now, if this did not come out to be infinite, if you actually came out to get an x value, then you would take that value and you would go plug it back in and find your y's and your z's. So don't think that all non-squares will be an infinite number of solutions. For our last example, we're going to work with some financial information. We have a small business that borrowed $30,000 to renovate its building. Some of the money was borrowed at 7%, some at 9%, some at 12%. And then we know the amount borrowed at 9% was $1,000 greater than the amount borrowed at 12%. And we are trying to find out how much was borrowed at each rate if the total interest owed for the first year was $2,960. So that's a lot of information. We are going to have 3 variables, 7, 9, and 12%. So over here, I'm going to let x be the amount at 7%. I'm going to let y be the amount at 9%. And I'm going to let z be the amount at 12%. So when we're working out the equations here, x represents 7%, y represents 9%, and z represents 12%. So let's set up our equations and see what we have going on. We borrowed a total of $30,000. So we borrowed so much at 7%, so much at 9%, whoops, let's try that again. So much at 9%, and so much at 12%, and we borrowed a total of $30,000. So there's our first equation. Now let's write an equation dealing with the percentages. So we had 7% times that amount of money plus 9% times that amount of money plus 12% times that amount of money, and that's going to equal the total amount of interest that we owed for that year, which was $2,960. So the first equation was for the amount of money that we borrowed, and this second equation dealt with just interest. So the third equation, the amount of money borrowed at 9%. Now the amount of money we borrowed at 9% is our y. So the amount of money we borrowed at 9% was 1,000 greater than the amount borrowed at 12. Well, the amount borrowed at 12 was z, and then 1,000 greater. So there's our 3 equations. Now we get to try to figure out how much was borrowed at each amount. When you look at these, you need to figure out how you're going to go about solving them. Do you want to solve them using the elimination method or some other method? I look at this and I see that I have y equals z plus 1,000, so this to me is set up to substitute. So I'm going to plug in z plus 1,000 in for this y and this y. So I'm going to substitute in for both y's. So I'm going to come over here and substitute in for the first y in this equation, in the first equation. X plus, always put parentheses when you substitute in for this y, z plus 1,000 plus z equals 30,000. And simplify that, that's going to be x plus 2z, subtract 1,000 from 30,000, and that's 29,000. So that's the first equation simplified after you substitute in for y. And let's take the second equation here, substitute in for y, and see what we get. So I'm going to have 0.07x plus 0.09, and I'm going to put parentheses. I'm going to kind of separate this a little bit here. I'm going to put parentheses where I'm plugging in for y. That's z plus 1,000. Clean that up just a little bit. Okay, plus 0.12y equals 2960. So let's simplify this a little bit. Distribute the 0.09, 0.07x plus 0.09z plus 0.09 times 1,000 is 90 plus 0.12y equals 2,900 or 2,960, sorry. No x's to combine, so 0.07x plus, oh wait, that's a z. That's supposed to be a z way up here. If y'all were in class, y'all would have hollered at me about that. Hopefully y'all caught that way back when. That was supposed to be a z, wasn't it? Let's fix that. That's one thing about doing videos. Y'all can't say, wait, that's wrong. Okay, so that's supposed to be a z. Okay, because this is at 12%, so 0.12z. 0.12z, there we go. All right, so 0.09z plus 0.12z is 0.21z. That's 0.21z. And we need to subtract 90 from 2960. Subtract 90 from 2960, and that's 2870. So now we have these two equations that have only x's and z's. And what we need to do now is put these two together. So we need to put these two together and work on these two just solving for either x or z. And so we can get this simplified down and figure out what's going on here. So we have x plus 2z equals 29,000. And then we have 0.07x plus 0.21. Let's try again. 0.21z equals 2870. And again, I mean, y'all have a lot of options here. I mean, you get to decide how you want to solve this. I mean, just because I solve it a certain way does not mean this is how you have to solve it. I am deciding to do this by elimination method. I'm going to get rid of my x's. And to get rid of my x's, I'm going to multiply this top equation by negative 0.07 so that these x's will cancel out. So I've got to multiply this whole top equation by negative 0.07. If I do that, and I'm going to just bring it right down here, that's going to be negative 0.07x minus 0.14z equals negative 2030. And I didn't do anything with the second equation, so I'm just going to leave this alone. And now I'm going to add those two together. So the x's will cancel out. The z's, you're going to have 0.07 z equals 2870 minus 2030, or plus negative 2030, is 840. Divide that by 0.07 and your z is 12,000. So I know this problem is kind of long, but it's really important that you do this because I can guarantee you on a quiz and a test you're going to have problems like this. So this is a type of problem where you don't just tell us x, y, and z. Answer the question, how much was borrowed at each rate? So z is 12,000 and z is 12%. So you need to tell me that you borrowed, or he borrowed, or she borrowed, they borrowed $12,000 at 12%. So now you need to tell me how much did they borrow at 9% and how much did they borrow at 7%. So I know these notes have been pretty long. I'm going to try to shorten it up as best I can here to finish up. So at this point, you just take the 12,000, you go find you some equations to go plug it back in, and y'all should be able to finish it up from there. Go plug 12,000 in. How about right here for y? 12,000 plus 1,000 would be 13,000. And then 13,000 plus 12,000, that's 25,000, and the total is 30,000, so that means you only have 5,000 left. So there is the total amount of all the money that you borrowed. And that is it.